For number one, what do we do in number one? John.
A squared plus B squared equals C squared.
Yay, what is that called? Yeah, buddy. So a squared in this case, we're going to make what?
R2
Okay, so r squared plus
12, 2 equals 13.
Okay, why did the 13 have to be the C? Very good, and it's also the hypotenuse. Excellent. So when we square these, we should get r squared plus 144 equals 169. Then what do I do? Subtract the 144. Very good, John. What do I get?
You get 25.
25 equals r squared. Then what do I do? Square root of both sides, and we get r equals 5. Hey-yo. How many of us got that 5? Raise your hands. Yay. If we didn't, what questions do we have? Talk to me. We're Gucci? All right. The second one. Hannah? Yes, it is. Why is it a 45, 45, 90, Hannah?
It's isosceles, and the one angle is 90, so the two base angles must be 45.
Excellent. It's an isosceles triangle.
As to how I don't remember how to get it.
You don't remember it? Dylan, do you remember? You did it a totally different way, and we will get to that way, and I'm glad that you said that. Sophia? You did it the other way? Did you do r squared plus r squared equals 18 squared? Okay, good. Did anyone do it the 45, 45, 90 way? Okay, then write this way down as well as the way that you did it. So, because it's a 45, 45, 90, that makes each of the legs, we're going to make them little a's. Do you guys remember that? Little a, and the hypotenuse is little a times the square root of 2. Now, let's solve, because they gave us the hypotenuse was 18. Let's solve for little a and the hypotenuse, right? How would you solve for little a and the hypotenuse? What's that? No. So we want to solve this equation. Like, let's solve this equation for a. What would we have to do to solve this equation for a, guys? Who said divide? Good one. We divide by what? Very good. Divide by the square root of 2. So now in your calculators, plug in 18. Can you do it for me? 18 divided by the square root of 2. German, you're going to be my calculator person for today. Yeah? Yeah. Mm-hmm. And click enter. 12.7. A equals 12.7. All right, now, there was another way to do this problem. Dylan, can you walk me through what you did?
18 times 18, I forgot what it's called.
Squared? Mm-hmm.
You get 324 divided by 2, and then you square root.
Oh, so you divided it by 2 and then you took the square root of it?
Yeah.
Perfect. Okay, but let's see why we're able to do that. 18 squared, just as my hypotenuse, should be equal to r squared plus r squared, my a and my b, right, in my triangle. R squared plus r squared is 2r squared. Then we divide by 2, like you said. What did you get here, 122 or 162?
Yeah, 162.
162 equals this, or r squared. And then we take the square root of both sides, and you got 12.7 equals r, okay? You'll get the exact same answer regardless how you do it, okay? But this is how you get both answers either way. What questions do we have on the second example? So 11.1 is all about circumference and arc length. How many of us have heard the word circumference before? Does anyone know what it means? Hannah? Very good. It's the distance around a circle. So before we talked about the degrees around a circle. How many degrees are in a circle? 360 degrees. But guys, circumference is not degrees. Circumference is length. So like, yeah, it takes like 360 degrees to go around a circle, but how many inches is that? How many feet is that, right? We're actually going to be calculating the total distance around a circle. So circumference and degrees are different. Now, arc length, when have we heard the word arc before? In the last chapter, right? What did arc represent? What was an arc? Yeah, it was the edge, but was it the whole circle? No, it was a piece of the circle. So now an arc length is going to be a piece not of the 360, but of the circumference, okay? So it's going to be the length of the arc, the actual physical length in inches, meters, feet, whatever units, it's going to be the distance of an arc, okay? All right, so, ooh boy. All right, so the circumference of a circle. There's two formulas for the circumference of a circle, okay? And circumference, as we just talked about, is the distance all around the circle. Now, the circumference of a circle can either be written as C equals pi times D. Who thinks they know? Remember, this is for circles. What D represents? Diameter. Very good, okay? It is a form of distance, whoever said distance, okay? You're not wrong. And what about 2 pi r, where r represents what? Radius. Very good. Those are the exact same formula. Does anyone know why? Yep. Very good. If you multiply the radius by 2, you're just dealing with the diameter. So guys, you only need to know one of them, right? And you can automatically get the other, okay? So pi times the diameter is the circumference, or 2 pi r, which is 2 times the radius, times pi, okay? Now, pi is a symbol. How many of us have seen the symbol pi before? Okay, if you have not, okay, pi is a ratio that we use for these circles, okay, and it helps us figure out the circumference of a circle. It's a number, okay, but it is irrational. Now, an irrational number is a number that's non-repeating, so it doesn't repeat itself, and it's also non-terminating. That means it is a decimal that will never end. Nobody knows the end of pi, okay, but you can get as far as you want, but nobody actually knows the very end of pi, okay? And irrational means you cannot write it as a fraction either, okay? Now, I want us to take out our calculator, so if you have your calculator with you, please take it out at this time, okay? Pi, for our sakes, is either going to be, you're going to have 3 possibilities for your answer. Your answer could say, okay, I want you to leave it in terms of pi. That means that pi will be part of your answer. They're going to tell you, okay, approximate pi using 3.14, which means that anytime you see the pi symbol, you're going to approximate it with 3.14, or it's going to say, I want the exact value of this answer, which means that you're going to use the pi symbol from your calculator, okay? Now, on your calculator, I want you to locate the pi symbol at this time. Oh, and I need light for this. Then you would not use the pi symbol. You would physically type in 3.14 wherever you see pi in your equation, okay? Those are 2 different scenarios, okay? So the value of pi in your calculator is a non-repeating decimal. It goes as far as pi is. But when it asks you to plug in 3.14, you have to chop off at 1/4 and not use the pi symbol. Are we clear on that? Okay, so let's check out before our first example, let's talk about arc length. So arc length is a portion of the circumference of a circle. It's not the full thing, it's just a piece of the circle. And you can use the measure of an arc in degrees to find its actual arc length in linear units. For example, inches, meters, feet. Arc length in a circle is the ratio of the length of a given arc to the circumference, and it's equal to the ratio of the measure of the arc to 360 degrees. So the formula, and the one that I want you to box in, is this one on the right-hand side. The reason that there's 2 here is to show you where this formula came from, okay? So this formula comes from taking the length of an arc, for example, AB, divided by the whole length of the entire circle. Do you guys agree that the entire length of the circle is 2 pi r? That's our circumference. We can put a C there. Do you guys agree that that's the same as circumference, 2 pi r? Hello?
Yes.
Yes.
2 pi r?
2 pi r is the circumference, right? And circumference is the distance all the way around the circle, correct? Correct. No, that's 360 degrees. That's different. Circumference is the distance around the circle. So like it's 360 degrees, but how many inches did you move? Right? So degrees is different. Degrees is an angle, right? Degrees isn't like a physical measure of like, if I told you I walked 5 degrees right now, what would that mean? You wouldn't know, right? But if I told you I walked 5 feet, you would have an idea of what I'm walking, correct? If I told you you're 5 feet tall, that makes sense. Would you know how tall you are if I said you are 5 degrees? So length is different than measure, right? Measure is like the degrees in terms of a circle, like how many degrees did we turn to get to this spot on the circle? The length is different. So how long, far did you travel, okay? So how we use this formula, okay, is we say the measure of the arc divided by 360. So the measure of the arc out of the whole thing, and then you multiply it by the circumference formula, which is 2 pi r. And you will see me a lot substitute for 2 pi r the letter C, which represents circumference, okay? Because remember, if you take your circumference and you multiply it by the ratio of the degrees over 360, that will give you the arc length. It's a portion of the entire circle. Okay, I will. So let's say AB, we knew it was 60 degrees, right? That means that arc is 60 degrees out of how many degrees in the circle? 360. So to find the portion that arc is of the entire circle, we would do 360 in the denominator and 60 in the numerator. Do you agree? That ratio, what we're doing with that is we're multiplying it by the circumference. Because then that's telling us, okay, circumference is the distance all the way around the circle. Do you agree? So if I started at B and I go all the way around the circle and I end up back at B, this is circumference. You're taking that circumference and you're multiplying it by a ratio, which is 60 over 360 times your circumference, which gives you just that part in the red. Do you see that? It'll only give you this part right here, and it won't tell you the length of the entire thing. Christian? You'll have to figure it out. So it'll give you the radius so you can find it.
Find the circumference first.
Mm-hmm. And then multiply it by the ratio. Yeah, go ahead. Set a timer, please. What other questions do we have so far? Okay, I promise it'll make a little bit more sense when we do some examples. So let's take a look at example 1. It says find the circumference of a circle with a diameter of 5 inches and leave your answer in terms of pi and then use 3.14 for pi. So we're going to have 2 answers here. We're going to leave it in terms of pi and we're going to use 3.14 for pi. We are not going to use the calculator stored value of pi. So circumference of a circle with diameter. What is the formula for circumference that also involves diameter? Nick? C equals pi times diameter. Very good. So C equals pi times diameter. And what is the diameter for this problem? D equals 5. So we're going to take 5 and plug it in for D. So C is equal to pi times 5. So if we're going to leave this in terms of pi, make sure the numerical portion comes first. C is equal to 5 pi. That's it.
That's the answer.
That's the answer in terms of pi. Now the second part of the answer was it says it wants you to use 3.14 for pi. So let's substitute it in. We're going to say that circumference is also equal to 5 times, what am I substituting for pi? 3.14. And in your calculator, you have to physically type this one in there. You cannot use the pi symbol because the pi symbol will use the entire value of pi, and you just want to use 3.14. Multiply 5 times 3.14. What do you get?
15.7.
15.7 is correct. I'm missing one thing on both of my answers. What am I missing? What? Not degrees. What? Yes, it's units. What units does it need? Inches. Very good. Inches here. We're going to put IN and inches here. Because remember, circumference is not degrees. It's not the measure of the arcs. Yes?
So if it's asking you to use pi, make it equals
No. In terms of pi would be the red answer, 5 pi inches. Okay?
if it doesn't, if it doesn't say leave your answer in terms of pi, then we do that.
No. If it didn't say in terms of pi or use 3.14 for pi, you would use the pi button on your calculator.
So if it doesn't say either of those two, just use pi.
So go ahead and multiply 5 times the pi button on your calculator, and you should get a different answer. Go ahead, Kristen. All right. Part B says find the radius of a circle with a circumference of 17 pi feet. So now we're starting with the circumference. We now have to find the radius. What's the radius formula for circumference? C equals what? Pi r squared? No, that's area. 2 pi r. Very good. Okay. And we know which of these values? We know C. C is 17 pi. So plug in 17 pi for C. We're going to get 2 pi r. So 17 pi equals 2 pi r. And we're asked to solve for the radius. We want to find the radius. So this is now just becomes an algebra equation. Remember, pi is just a number, so you can treat it like a number. How could I solve for r here? Daniel?
Isolate the r, so divide by 2 pi.
Excellent. Divide by 2 pi. What do you get?
17 pi over 2 pi.
Yeah, 17 pi over 2 pi. Because these 2 pi's are going to cancel. We're going to get r equals... Guys, what happens on the left side? What's 17 pi over 2 pi? Does anything cancel out? The pi's cancel out. So now you just have 17 divided by 2.
2 pi or just 2? Oh, the pi's cancel out.
Did you get 8.5? 8.5. What am I missing? Very good. Feet. You have to add in the feet here. So our radius is 8.5 feet. What's the diameter of this circle? 17. Very good. How do you get from the radius to the diameter? You multiply it by 2. Okay? And you can do vice versa. So if you found the diameter, you could just take that diameter and divide it by 2. Okay? German, can you in your calculator plug in 17 pi divided by 2 pi and see if you get the same answer? And you guys try it as well. 17 with the pi symbol divided by 2 pi. You did not? You got 83.9? Okay, this is a very common mistake. Let me show you on your calculators why this. 2 more examples. These examples involve arc length, okay? So we're going to talk about arc length. It wants us to find the indicated measure of the arc. So we're going to find the arc length of AB. Let's remember the formula. So it says length of AB, the arc, is going to be equal to the measure of the arc AB over 360. That's the measure of the whole circle. The circumference. Very good. Let's put C here. Daniel, go ahead. That's an arc AB, yeah. Okay. Do we know the length of AB? No, we're trying to find it. So that's going to remain as our variable. So we're just going to leave it as length of the arc AB equals. Do we know the measure in degrees of the arc AB? It's 60 degrees. How do you know it's 60 degrees? That's not the measure of the arc. That's the measure of the angle. APB. Why would these have to be the same?
Because it's coming from the center.
What would you say? It's a central angle. Thank you, German. Okay? It is a central angle. So it must also be 60 degrees here. So it's 60 over 360 times, what formula do you want to use for circumference? 2 pi r. Why 2 pi r? It gave us a radius, right? It gave us 8. So let's use 2 pi r here. And instead of r, I'm going to substitute it in the 8 centimeters that it was. Yep, that's 2 pi r. All right, so now in your calculator, you're going to use the pi symbol. I want you to do 60 divided by 360, multiplied by 2 pi, and also times 8. What'd you get, Christian? 8.4 if you round it to the 10th. I think I got that too.
8.34.
Can anyone confirm that? German, you're good? Okay, what units does this guy need? Centimeters. Hey now, can I explain what we just found? We knew at the start that the measure of this arc, the measure of it in degrees was how much? How much? How many degrees with that arc, the red arc? 60 degrees. But now I just found the length of it, which is different than the degrees, the length of it, if you were a human walking along this arc, the distance you would have to travel is 8.4 centimeters. 8.4 centimeters. Talk to me. What questions do we have on this first example? Cody?
So 2 pi r, use the 2 pi r since it gives you 8 centimeters.
Correct, because it gave us a radius, not a diameter. I mean, you could technically, if it gave you the radius, just multiply it by 2 and use 16 pi. It's not hard, right? So you can use either one that you want. I'm just going to use whichever value is given to me, okay? Good question. What other questions do we have? Okay, let's check out B. In letter B, it wants us to find the circumference of the circle Z. All right? But it gives us the arc length and it gives us the measure of the arc. So let's set up the exact same formula. It's going to be the length of what arc? XY equals the measure of that same arc XY over what? 360 degrees times what? 2 pi r. Instead of 2 pi r, let's use C. What are we trying to solve for? Circumference. So do you guys agree that if I leave this as C, as long as I solve for C, I'm going to be fine? So it's advantageous to leave it as C and not to leave it as 2 pi r. So let's find the length of XY. We know what the length of XY is. What is it? 4.19 inches. Very good. Equals, what's the measure of the angle? 40 degrees over 360 degrees times our circumference, C. Remember now, we're solving for this variable, C. What can I do to both sides of the equation to solve for the variable of C, to isolate it? Multiply by what?
360.
Multiply by 360? Only? Over 40. What do we call that? The reciprocal. Very good. We multiply by the reciprocal so that the 360s cancel, the 40s cancel, and we do it to the other side. Multiply by 360 over 40. So now in your calculator, you're going to multiply 4.19 times 360 and then divide it by 40. 37.71. Let's round it to 37.7. Let's put inches and we're done. German, can you confirm the 37.7? Thank you. In a calculator? Huh?
4.94.
Yep. Take 4.19, multiply by 360, and then divide it by 40. Okay? What questions do we have on this example? Okay, letter C. The measure of the arc RS. Let's be very careful here. How many letters did it use to identify the arc RS? 2. That means it has to be what kind of arc? Minor. Is it talking about the top half of RS? Or the bottom half? Why the blue one? It's smaller than 180. Very good. Keep that in mind, guys. The notation absolutely matters. So if we're finding the length of RS, we're going to put length of RS, the arc. It's equal to what? What's the formula? Yep. The measure of RS divided by 360 times C. Okay? Very good. And in this case, guys, we are looking for the measure of RS in this case. So we're going to have to solve for this variable. Okay? Do we know the length of RS? What is it? 44. So let's plug that in. It's going to be 44 equals the measure of RS over 360 times, do we know the circumference? We can know it. How? We have the radius. Very good. What is the measure of the radius? 15.28. So what is the formula for circumference in terms of radius? 2 pi times the radius. Very good. And in this case, we know the radius was 15 point, what was the other? 28? 28. Now, guys, I'm confident that a lot of us can get to this stage. But what I'm starting to think is that a lot of us are going to struggle with solving for that variable, RS, the measure of RS. And it's specifically using these values in our calculator. So what I want us to think about is you're going to have to divide and multiply. So this value, the measure of RS, is our variable that we're solving for. What can I do so that I can isolate it? What can I do so that I can isolate it? I definitely need to multiply both sides by 360. Very good. If I multiply both sides by 360, that 360 in the denominator is now poof, gone. What else do I need to do to isolate the measure of RS? Divide by what? 2 pi times 15.28. These go away. 2 pi times 15.28. Now, guys, I want you to plug it into your calculator, but I want you to make sure that your denominator, what did we say in the calculator it needs to have around it? Parentheses. So you're going to do 360 times 44 divided by, open up your parentheses, put 2 pi times 15.28, close your parentheses. Dylan, what's up? You got it? What'd you get? 165 degrees? I believe that's correct. The measure of RS should be 165 degrees, approximately. But let's put 0.0. Because did you round it to the 10th? It should have been like 0.98 something, right?
Yeah.
164.98. So if we rounded it to the 10th, it would round that 9 up, so it'd be 165.0. German, you got the same thing? Okay. Talk to me. What questions do we have? Hannah. How do I remember all of it? It's really only 2 formulas, Hannah, okay? You need to know the circumference formula, which is 2 pi r. And you need to know the arc length formula, which is the measure of the arc over 360 times the circumference. Okay? Yes, Sophia. Yes. So you should have plugged in 360 times 44 divided by, make sure you have parentheses, Sophia, around 2 pi times 15.28. Let me know if you get the 165. You did? Yay. Okay. 0.98. Perfect. Go ahead. What else? We're going to take our time with this lesson, guys. It's very, very important. We're Gucci? All right, moving on. More examples. Example 2, find the diameter of a circle with a circumference of 16 feet. Use a calculator and round to the nearest hundredth. Did it tell us to leave our answer in terms of pi? Did it tell us to use 3.14 for pi? So what are we going to use for pi? The calculator pi, okay? We're going to use the calculator pi. So let's set it up. What's the circumference formula involving diameter? What? Pi times d. C equals pi times d. And what piece of information did they give us? What is 16 feet? The circumference. So we're going to say C equals 16 feet. We plug that into our formula, so plug it in, guys. You're going to get 16 equals pi times your diameter. What are we solving for here? Your diameter. Very good, your d. How do I solve for d? Divide by pi. Divide by pi. So in your calculator, what are you going to plug in? 16 divided by, and then use the expression for pi. German? Huh? 5.09 feet. Why did German round to the nearest hundredth and not the tenth here? It says round to the nearest hundredth, okay? If it does not say to round, what are we going to round to? The nearest tenth, okay? But if it says specifically what to round to, you have to understand to round to that. Questions? Talk to me. All right, how would you find the radius? Divide 5.09 by 2. Remember, 2r is equal to your diameter. So if you get the diameter, divide by 2. If you get the radius, multiply by 2, you've got the diameter, okay? All right, part B says a car tire has a diameter of 28 inches. How many revolutions does the tire make while traveling 500 feet? Use a calculator and round to the nearest tenth. I am going to draw a picture because I'm a picture person. So draw a car tire. You can probably draw better than one than I will. Give it some rims. And then draw a diameter through that car tire. What did it say the length of the diameter was? 28 inches. And then it wants to travel 500 feet. So we're going to draw a length of space. It wants to travel all 500 feet. Okay? So it's asking how many times would this tire, right, have to, like, how many revolutions would it go through in order to get to the end for 500 feet, right? So we need to know how much would one revolution be? How far would it travel in one revolution? So if you start here and you revolve all the way around the tire, what is that distance?
If you do 1 360.
What?
If you do 1 360.
Yeah, so a whole 360 degrees, right? But remember, we're not going to measure this in degrees because degrees and feet, right, they're different units. So what could we find about this circle that would help us with this problem?
28 divided by 360.
No. The radius. What is the radius here? 14 inches, right? Hannah? Oh, you're just stretching? Do you guys see the blue arrow that I drew around the circle?
Yeah.
What represents that? The circumference. So do you guys agree if a tire rotates, it's full all the way around, it's gone one circumference? It's traveled around one full time? And it's also traveled that distance on the ground because it rotated that amount of, that length around on the ground, correct? So if our car rotates that distance, as long as we find the circumference, we're going to find how much it travels in one revolution, okay? So circumference equals 1 revolution. Before we start calculating the circumference, guys, these were not given in the same units. One was given in inches and the other one was given in feet. You only have to convert one of them. Which one would you like to convert? Inches to feet? Okay. So change this 28 into feet. How do we change a 28 inches into feet? Divide it by 12 because there's 12 inches in a foot. So you would do 28. Go ahead and plug it into your calculator. 28 divided by 12. What does that give me? 2.3. 2.3 what? Repeating. And then that is feet. Okay, so now let's use our circumference formula. So our circumference formula is pi times the diameter. In this case, it's going to be pi times 2.3 repeating. So in your calculator, make sure you use the 2.3 repeating and you don't round that number. So if you have to plug it in again, it was 28 divided by 12, and then multiply that by pi. 7.2? German? 7.2? Feet. Yep.
I didn't get 7.2.
What did you get?
7.3.
Did you use 2.3 or 2.3 repeating?
I did 28 divided by 12 times pi.
Okay, that line on top of the 3 just means it's a repeating decimal. So this is like 2.33333, and it goes on forever, right? That's what that line means. Yes. You leave the answer stored. So if you need to type it in again, just do 28 divided by 12, and you'll get that exact answer stored again, and then just multiply that by pi. Okay, so now we found out how long it takes for one revolution, right? It's 7.3 feet. How do we find out the number of revolutions it'll take to reach the full distance? Cody? Divide what? Very good. Divide the 500 by the circumference, and that'll give you the number of revolutions. So if you do 500 divided by that 7.3, 68.5, 68.5 revolutions. All right, this is where we're going to stop for today, guys. So previous slide, we did a few examples. We actually divided by pi here, and we multiplied by pi here, okay? And that gives us decimals, okay? In example 3, we're going to find different lengths, okay? And we're going to use the arc length formula. So let's take a look at example A. It says, find the indicated measure and keep your answers in terms of pi. So are we going to have pi as part of our answer? Yes, so your answer could be like 12 pi, right? Pi is going to be part of your answer. You're not going to actually plug it into your calculator and get a decimal, okay? All right, so let's find the length of PQ. PQ is this arc right over here. What could we do to find the arc length of that arc? Kristen? The diameter is 9, so D equals 9. Very good. Circumference is going to be pi times 9, or pi times diameter. So circumference is going to be 9 pi. Very good. So the whole thing is 9 pi, but Kristen, I only want this section here. Who remembers how to find the arc length of just a piece of the circumference? Jaden? 75 over 360. Yes. 5 Remember, the arc length, so arc length is going to be, you're going to have to take 75 over 360 and multiply it by the circumference, which we just found. Kristen found it. It was 9 pi. So now all we have to do is multiply 75 and 9 and then divide that by 360. So our arc length is going to be 75. Let's plug it into our calculator. 75, divide that by 360, and then multiply that by 9. I got 1.875, and then we have pi at the end. And then lastly, guys, what units should be on that answer? Yards, very good, okay? Yeah. Can you simplify it to 1.90? No, Hannah, because it didn't say to round, right? So you want to include all of those decimal places if it doesn't say to round, okay? I did 75, and then I did divided by 360. You click enter. And then once you have that answer, don't round it, just multiply it by 9.
Oh, just 9?
Correct. Don't multiply by pi because we want pi to be part of our answer, okay? So leave your answer in terms of pi. Yes, Amanda?
Why did you put the pi symbol after your answer?
Yep. So the pi symbol goes after my answer because of in the instructions, remember how it said keep your answers in terms of pi? Anytime it says that, pi should be part of your answer at the very end, okay? What other questions do we have? These are really good questions. Yes, Christian?
When it says keep answer in terms of pi, that also means you don't multiply by pi, right?
Correct. Okay, so our answer, if we were to multiply by pi here, 1.875 times pi, we would get a different answer. We want to leave it in terms of pi. Okay? Yes?
Do we always leave it in terms of pi?
No, no. So like, it will tell you exactly what to do on the exam. Okay? All right, example B. Let's find the circumference of the circle N when we're given the arc length and the measure of the arc in degrees. So we're still going to use the arc length formula, which says that the arc length is equal to the measure of the arc. What's the measure of the arc that we know? 270, and it's from M all the way to L. So we're going to put 270 over what? Good, 360, and then multiply that by?
Is that 60 or is that like 60?
That was 60, yeah. Wait, oh, this is 60 pi. Is that what you were asking?
Yeah.
Yeah, that's 60 pi. What goes after the 270 over 360 in our formula? C, very good, our circumference. Correct. We already have the arc length, but we don't have the circumference. Do you agree? And that's what we're trying to find. So let's plug in our arc length, which Diana said we already knew, 60 pi. So let's plug in 60 pi equals 270 over 360 times C. What questions do we have so far setting this guy up? Does everyone see where I got the 60 pi from? Does everyone see where I got the 270 from? Okay, now comes the algebra part, and I need us to be very proficient at this. We talked about a few examples yesterday. How do I isolate C here? What do I need to do? Hayden? Multiply by 360, not just 360, Hayden. Over 270. Does anyone remember what that's called? What we called it in algebra? The reciprocal. Very good. So we multiply by the reciprocal to both sides over 270. Guys, what was the significance? Why is this so important that we multiply by the reciprocal? German? Perfect. It all cancels out. The 270s will cancel out. The 360s will cancel out. Now I just have C. I know what my circumference is as long as I multiply it. Guys, we still need our answer in terms of pi. Do you guys agree? So am I going to plug that pi into my calculator? No, you're only going to do 360 times 60 and then divide it by 270, okay? So let's do it together. 360 times 60 and then divided by 270, you should get 80. So it's 80 pi. Let's always look back and see if that answer makes sense for this problem. Guys, would it make sense for an arc length to be 60 pi, but the circumference to be larger as 80 pi? Why would the circumference be larger?
Because you're missing a piece.
Because the circumference is the whole thing. An arc length is just a piece of the circle. Do you guys agree? So it should be smaller. Talk to me. What questions do we have on this example? Would I get this question completely correct? No. What am I missing? The units, which were meters. Okay, make sure you put an M there next to the pi. Yeah, Sophia.
Why do you multiply 60, like 360 and then divide it by 270?
You could divide first. You could do 360 divided by 270 and take that value and multiply by 60.
Oh, it did the same thing.
It would be the same thing. Okay. Ronnie?
Why did you times like C after 270?
Why did I times C? Can you tell me where you're looking right now? Oh, yeah, so that's the formula, right? You're talking about this piece right here? So the formula says that the measure of that arc, which was 60 pi, right, is going to be the ratio of the degrees over 360 times the whole circumference, okay? Now, sometimes we don't use this C here. Sometimes we'll use like 2 pi r or pi d, depending on what we are given in the problem, okay? Good question. What else? Yeah. Well, in this case, I knew I was going to use arc length because it gave me an arc length, but it didn't give me circumference. Okay? So depending on what it gives you. If it was just asking for the radius and it gave you the circumference, you know you're just going to use the circumference formula. Okay? You won't have to deal with the arc lengths. These are really good questions. What other questions do we have? Okay. Moving on, example 4. Guys, we kind of already did A, so cross A out. Let's go ahead and do the second one, B. It says, find the indicated measure. We are going to use a calculator and round our answers to the nearest tenth. Are we going to use pi in our calculator for this example? Yes, because we're rounding to the nearest tenth. It doesn't say leave our answers in terms of pi. Yeah, Scott? Sure. Okay. Set a timer, please. So let's go ahead and try to find the radius of the circle G. Do we know the circumference right now? No. What were we given in this example? We were given an arc length. So let's use the arc length formula. The arc length formula says that arc length is equal to the measure of the arc, which in our case is going to be EF, divided by what? 360. And we multiply that by the circumference. But now, guys, we want to find radius. We don't want to find circumference necessarily. Instead of putting C at the end, what can I put instead? That would involve radius. 2 pi r. Because remember, 2 pi r is the same as circumference, okay? So this formula is changing, okay? Sometimes we're going to need it looking one way. Other times we're going to need it looking another. All right, now let's plug in. What was the length of the arc? 10.5, so put 10.5 there. Equals, what was the measure of the arc? 150 over 360 times, and now we have 2 pi and r, where we don't know what r is, okay? So guys, for some of you, this is going to be the hardest part, is setting it up correctly, okay? For others, it's going to be doing the step after this to go ahead and solve for r. So now our mission is to isolate r. What can I do to isolate r? The reciprocal, very good. What would be the reciprocal here? 360 over 150. Boom, this cancels, boom, boom, boom. So multiply this side also by 360 over 150. So now let's go ahead and multiply it out. It was 10.5 times 360 Divide that by 150. 25.2 equals 2 pi r. We're not done though. Good, Dylan. We have to divide by 2 pi. Excellent. Divide by 2 pi, divide by 2 pi. So now r is equal to, and plug into your calculator. Guys, this is where we have to be careful. Make sure if you're dividing by 2 pi in your calculator, you put parentheses around your 2 pi. If you don't have the ability to put parentheses on your calculator, divide twice. Divide by 2, then divide by pi. I have the ability to put parentheses, so I'm going to put parentheses around my 2 pi. I got 4.01. What did it say to round to? The nearest tenth. What does 4.01 round to? 4.0. What am I missing in my answer? Units. What units do I need? Feet. Look back at the question. Does that make sense based on the part of this question? If that arc length was 10.5, would the radius kind of sort of be around 4? Would this piece look to be around 4.0? Yeah, I would say it pretty much, okay? Always go back and check, does it make sense to the context of this problem? What questions do we have? Gio?
For questions like these, will they tell us the circumference, the radius, or
So it listed the radius, right? So that's how I knew I had to put the 2 pi r there, okay? It'll tell you exactly what it's looking for. Good question. What else? Okay, cool. Guys, the next thing that we're going to talk about, and it's very, very simple, is something called a radian, okay? So a radian, right, is just another way of expressing an angle. And radians become very, very important when you guys get to Algebra 2 and pre-calculus, okay? Right now, we just need to be able to convert from radians to degrees, okay? And vice versa. So in order to do that, right, if you're going to convert from degrees to radians, you're going to use one of these two ratios. Either 2 pi radians over 360 degrees or pi radians over 180 degrees. And then the second one that you could potentially use is if you're going from radians to degrees. Going from radians to degrees, you're going to multiply by 360 degrees over 2 pi radians or 180 degrees over pi radians, okay? So let's do this in action, okay? In example 5, it says we need to convert 15 degrees to radians. I always set these problems up the same exact way. I'm going to write 15 degrees nice and big, and I'm going to multiply, put a multiplication symbol, and I'm going to put my fraction bar. I no longer want my answer to be in degrees. Do you guys agree with that? I want it to be in terms of what? Radians. So I'm going to put radians in the top, in the numerator. And in the denominator, I don't want degrees to be there anymore, so I'm going to cancel that out. I'm going to put degrees in the denominator. Do you guys agree that those 2 degrees, since one's in the numerator, one's in the denominator, they'll cancel out eventually? Perfect. So now you just have to remember your ratio. If I want to put pi radians up top, what do I have to put below? 180 degrees. Now, you only have to remember one of the ratios. So you could put 2 pi in the numerator, but how would that change your denominator? It would be 360, okay? All right, so now we're just going to multiply through. So you multiply 15 times pi, you get 15 pi. The degrees have canceled out over 180. And now we just need to go about simplifying this expression, okay? What's a common factor between 15 and 180? They're both divisible by 5. So we divide 15 by 5, we get 3 pi. Do you guys agree? And we divide 180 by 5, what do we get? You have a calculator. 36. Can we continue to simplify?
Yeah.
We sure can. What is the common factor between 3 and 36? 3. This becomes a 1. This becomes a 12. So our answer is pi over 12. That's it. Okay? And now it is in radians. Guys, your radian answer should always have what in them? pi, okay? They should always have pi in your answer, okay? Will degrees have pi in our answer? No. No. Degrees should never have pi in your answer. Yes? Where did I get 180 from? That's just the standard ratio. You can use 2 pi over 360 or pi over 180 for your radians to degrees, okay? We're going to use that same ratio in the next problem, okay? So pay attention to where the 180 goes. In example B, we're converting from radians to degrees. So check this out. I'm going to write 4 pi over 3. I'm going to put the words radians, in the numerator. I want to multiply by a ratio. What units needs to go in the denominator? No. Radians. What units needs to go in the numerator? Degrees, okay? Do you guys see how this works? Your numerator, whatever you pick, will be what you're changing into. Your denominator is what you're canceling out. Do you guys agree that these radians will cancel? Cool. So now my answer should be in what? Degrees by the end of it. Now I put what Christian was saying. I put the 180 up top. What goes below? Pi. And then, guys, before you multiply through here, let's try to cancel some stuff out. What's going to cancel that's the same between the numerator and the denominator? The pi's will cancel, so my pi is gone. Anything else? The 3. 180 is also divisible by 3. What is it? 60. So now I'm just multiplying 4 times 60. You can use your calculator. What do I get? 240. And what units is that? Degrees. Bingo, bango. How are we feeling? Talk to me on these last 2 examples. Is that a hand? No. Okay. Yes, Gio. How do you know when to use 360 or 180? That's completely your choice. You can use either one. But if you're going to use 360, Gio, you have to put it over 2 pi. Or vice versa, 2 pi over 360. So it's okay? To use 180. It's easier to use 180, yeah. What other questions do we have? Okay, people, you have to answer this last exit ticket, okay? I just need you to explain how the radius, central angles, arc lengths, and circumference of a circle are related. It can be as simple as, oh, they're all parts of a circle, okay? It could be as complicated as you use the radians to figure out this, to figure out that, okay? Whatever floats your boat, whatever means the most to you. Ronnie,